In a previous video, we used Plotnine to create a line chart from manufacturing data we read directly from a Fred public CSV file. In this video, we're going to go further. We'll work with a larger, messier dataset from the Bureau of Labor Statistics to do some real data cleaning and build a polished, faceted chart that you could drop into a Word document or a PowerPoint slide. The dataset is the Consumer Price Index, or CPI, which tracks price changes across categories like food, housing, medical care, and transportation. It's data most business professionals are already familiar with, and it's a great example of what publicly available government data actually looks like before you can chart it. Within our Python environment, we'll use the Polars library to load and clean the data, and the Plotnine library to build the visualization along the way. We'll run into a few issues that are worth seeing because they show up in real projects all the time. So let's get started. The BLS publishes CPI data as a set of plain text files at download.bls.gov. We're going to work with two of them, the main data file, which contains the actual index values, and a series file that maps series IDs to human readable labels. The main data file is called cu.data.to.summaries. You can download the file directly using the link shown on the screen, and I've also placed a copy of the link in the description. The series file is also available in the description as well. These are tab-separated text files, not CSVs, not Excel. Polars can handle them fine, but we need to tell it to use a tab as the separator. To follow along, save both files into a data folder inside your project directory. Once they're there, you're ready to start. Let's start a new notebook and import what we need. I'm going to import the Polars library, and then from Plotnine, I'm going to import all of the methods. Finally, we'll use TextWrap to help with some long titles. Now load the main data file. Because it's a tab separated, we pass the separator equals, and we're going to use the escape character T. Take a look at the shape of this data frame. You'll see it has over 280,000 rows, and that's a lot of data. Before we do anything else, let's check the column names. You'll notice the column names have leading and trailing white space, and that's an artifact of how BLS formats these files. We need to clean up those before we can reference them reliably. The Python list comprehension calls the strip method on each column's name string. Now the columns are named simply series ID, year, period, value, and footnote codes without any of the unnecessary spaces. The value column also has white space issues. Each number is padded with spaces. And there's one special value in here that isn't a number at all. So let's check what non-numeric values are lurking in the value column. The regular expression we're using is looking for strings that don't match the standard number pattern. We find exactly one, a dash character used by BLS to indicate a missing value. Now let's clean everything up in one chain. We'll strip white space from the string columns, cast the values to a float, and then using strict equals false to make sure that the dash gets converted to a null rather than throwing an error. We can also drop the footnote codes column, which we don't need. After fixing a couple of typos, we can verify the null count. We see the value column has 433 nulls, so let's check whether any of those fall outside of 2025. Since 2025 data is still being published, some months will naturally be missing. We get 0 rows. All 433 nulls are in 2025, and that's expected, and we can work around it in the filter step. The file contains thousands of different series, regional data, subcategories, seasonally adjusted data, and unadjusted variants. We only want a small subset, the top-level category summaries for the US city average, not seasonally adjusted. The series IDs in this format follow a naming convention. The ones we want all match CUUR 0000SA, followed by a single letter. We can filter for that pattern using a regular expression. We'll also restrict the date range to 2000 through 2025 and exclude the period M13, which is an annual average that appears in some years and would distort a monthly line chart. Let's see what series IDs made it through. The 10 series in this list include apparel, commodities, education and communication, food and beverage, other goods and services, housing, medical care, recreation, services and transportation. Those are the top-level CPI categories. This is exactly what we want, but next we want to add the category labels to make this more readable. The series IDs aren't great for chart labels. We need to join this information with a human-readable series titles that we get from the cu.series file. Notice we're using the infer schema length equal to 10,000 here. By default, Polar samples the first 100 rows to infer the column types. This file has some irregularities further down, so we tell it to look at more rows before deciding on the types. And you can see here we had to do the same column strip to take care of the leading spaces in the column names. Now let's clean up the metadata and extract a short category name. The series title column has values like apparel in US city average, all urban customers, not seasonally adjusted. We only need the first part, the word or phrase before the preposition in. That last line of code that has the string split splits the title on the phrase in and takes the first element. It's a clean, readable way to extract the label we need. Now we need to join this information to our filtered data. The join method combines two data frames based on a shared column. In this case, series ID. The onSeriesID parameter tells Polars which columns to match on, and how, set here to left, means we keep all the rows from the CPI final data frame, regardless of whether a match is found in the series metadata. Since we built our filter around a known series ID, every row will find a match. I typically use left join on the data frame I want to preserve. The column named period contains values like M01, M02, and so on. These are simply month codes, and we need to convert these to actual dates before we can plot them on a time axis. The approach here is to strip the M prefix, cast the value to an integer, and then use Pollar's date method to construct a proper date from the year, month, and setting the day to the first day of the month. The string.slice with an argument of 1 removes the first character, the M, leaving just the numeric string. We then cast it to an integer, and using Pollar's date method, assembles the 3 parts into a date value. String manipulation is one of those skills that comes up constantly in real data work. Column names with extra spaces, codes with prefixes you need to strip, titles you need to split. The Pollar's string namespace gives you a broad set of methods like strip characters, slice, split, and contains that handle most of these situations cleanly. That means you can solve a lot of string problems without reaching for regular expressions every time. And as you've seen in this video, a few well-placed string operations can take raw government data from unusable to chart ready. Before we build the final chart, let's do a quick exploratory plot to see what the data looks like. This gives us all 10 categories on a single chart. You can already see the general pattern. Relatively flat lines from 2000 through about 2020, then a noticeable upward shift across most categories starting in 2021. But with 10 overlapping lines and a shared y-axis, the chart is hard to read in detail. Some categories, like medical care and housing, have much higher index values and crowd out the others. This is where faceting becomes useful. Instead of plotting all 10 categories on one chart, we can give each one its own panel. The facet wrap function in Plotnine handles this. We'll also use scales equal to free y so that each panel has its own y-axis range. Without this, the categories with lower values are nearly invisible next to the larger ones. One more thing before we build the chart. Text can often be long enough that it overruns the space that's allowed for it to fill. We can use Python's built-in text wrap module to insert line breaks at a set width. Here, the textwrap.fill method inserts a new line character, the escape with the N, and Plotnine respects it in the facet titles. So let's apply it to the chart titles as well. A few things to note here. We're coloring by category and hiding the legend with the show legends equals false, since the panel titles already identify each category. In this case, a legend would be redundant. We're using the scale X timeline with the date breaks equal to 5 years. This keeps the x-axis readable. In the theme, we're setting the x-axis title to this blank element. This will remove the x-axis label since date isn't very informative here. The result is a tall, narrow chart, and this works well as a document figure. Here, I've simply copied it over into a Word document. The same chart can be reformatted for a wider context, like a PowerPoint slide. Here, we can simply switch from a 2-column layout to a 2-row layout and adjust the figure dimensions. The main changes here are now we have in-row equal 2 instead of in-column equals 2. We've changed the figure size to get a landscape aspect ratio. And I've also increased the size of the title. I've also changed the formatting of the date labels to basically a 2-digit year. To save either chart to a file, we could simply append the .save method and include a file name. I now have a chart that I can include in a PowerPoint. And this is simply done by right-clicking and copying to the output to clipboard. A key decision here was matching the chart's aspect ratio to where it was going. The tall, narrow chart fills a document column well. The wide, shallow chart fits a slide. Plotnine gives you direct control over both dimensions through the figure size and DPI, which makes it straightforward to produce the format you need. In this video, we worked through a real-world data pipeline, a large government data set with white space issues, a dash in place of nulls, cryptic series IDs, and month codes instead of dates. We handled all that in polars, joined in metadata to get readable to labels, and used Plotnine to build a faceted chart in 2 different layouts. If you found this video useful, consider subscribing. I'll be publishing more videos focused on building practical Python skills for business and marketing professionals. If you'd like to go deeper, I've written a companion book, Getting Started with Python on Windows 11, that covers these topics in more detail and includes additional examples and exercises. I'll include a link in the description. I look forward to seeing you in a future video.